Hi everyone. I'm Blaze I'm faculty here at UChicago. And actually, of all the section chairs, I'm now the longest tenured person at UChicago. So I'm a faculty for a bit over 3 years. Right, and so up next we have Andrew McNutt coming back to present another talk. And so Andrew, please feel free to go ahead and share your screen as I'm introducing you. So Andrew already been introduced. This time he's presenting Divining Insights, Visual Analytics through Cartomancy. So this paper is part of the proceedings of the alt.chi subconference, which is a venue for boundary pushing, intentionally provocative, and really fun work. All right, and so yeah, Andrew, why don't you just take it away?
Yeah, all right. Thanks, Blaze. Hi again. Like Blaze said, my name is Andrew McNutt. I'm a third-year PhD student here at UChicago. So our interactions with data are increasingly shaped by automated systems. An open question is how to give analysts the tools to interpret these automatic insights while also inculcating critical engagement with algorithmic analysis. Can you really trust what automation has wrought? What can be learned and gained by ceding agency to the hands of the divine? I'm here to talk about our recent alt.chi paper, Divining Insights, Visual Analytics through Cartomancy. This work is a collaboration between me and Tableau researchers Anne-Marie Cryan and Michael Carell. In this talk, we'll answer these questions and more. But before we get started, I wanted to expand on Blaze's definition a little bit. This is a somewhat strange line of work, as I'm sure you can tell. And given that you heard and will be hearing more traditional types of talks today, I want to make sure you understand the context of it. As Blaze said, it's from a subconference of Chi called alt.chi. Alt.chi is a medium for controversial or boundary-pushing papers that are sometimes fun, funny, or insightful, or serious, or weird, or lots of other things. For instance, the other side from a year or two ago commented on the black box nature of deep learning systems by conducting a seance right there at alt.chi, while Lickable Cities commented on HCI methodologies through absurdity. Some works are important and might not have found a home or an audience without alt.chi, such as this year's I'm Just Terrified of My Future, which in a series of unflinching first-person narratives describes violences people with disabilities face in academia. I describe these papers both because they're wonderful, and but also because I want to highlight the importance of having a venue for critical but sometimes playful work within a major academic venue. These comments and thoughts are important and should not be removed from the academic project by deplatforming. In particular, I started at my own field, Viz, engage more deeply in self-reflection, which might be well mediated by something like an alt-Viz at our big conference, Viz. Anyway, with this context in mind, we now may begin with a problem. People oftentimes find themselves in situations where they have data and they want insights, but they don't know how to bridge that gap. As good computer scientists, we can simply call on data visualization to save the day. Charts, visual analytics, graphs, perception, and more. And that should be the end of the story, right? Unfortunately, visual analysis is hard. It can require expertise to create effective charts, to transform and manipulate data, to do all the things that you must do as part of the analysis process to understand data effectively. Automated recommendation systems, which are a growing area of research, are an enticing way to get around these problems. Open up some software, drop in your data, get the insights you so desperately seek. These tools have begun to pop up in the likes of Tableau to Google Sheets and really just everywhere in between. But there's a problem with this approach as well. Effective automated analysis poses a challenging set of problems and requires you to be on your guard in new familiar ways. In particular, these systems are often opaque black boxes that make uninterpretable predictions. Why did this chart get chosen over another? While there is opacity in the action of ceding agency, the problem is possibly even worse as more analysis systems turns towards deep learning techniques, where the very idea of interpretability is ambiguous. These analysis systems can be inflexible to the needs of the domain the analyst is working in, providing general advice that might be irrelevant locally, or might arbitrarily promote particular charts due to arbitrary limitations in their implementation. The conclusions they promote can be brittle, crafted as they are by effectively evaluating every parameter configuration at once, creating a minefield of multiple comparisons problems and p-hacking machines. And what's worst is that we can be lulled into accepting these recommendations thoughtlessly because of the domineering manner in which they are presented. We trust them because of their literal and rhetorical power, which we have instilled onto these entities. So, with all these troubles, what else are we to do but cry out to the divine? Behold! Inspired by the hands of fate, we've constructed Sortilege, a web-based visual analysis system that mimics the act of using tarot cards for divination, but tuned to the process of investigating important data properties. Our system follows a common analysis pattern. A user, who we'll refer to as the querent, uploads a data set of interest. We then generate a new deck of tarot cards to aid in this search. The user then deals the cards into a spread, which then enables them to divine their insights. But before diving into all that, let's step back a little bit. What actually is tarot, or for that matter, cartomancy? Well, cartomancy is the use of playing cards, such as tarot cards or just others, for divination. Tarot has a long history and a corresponding sprawling collection of variations of detail, form, and interpretation. The design of our deck is guided by the ubiquitous Rider-Waite deck, although there are many others of note, following a wide variety of themes, designs, meaning, and many other contexts. Like traditional tarot decks, ours consists of 22 unique named cards and 56 numerical cards across 4 suits. We now consider each of these families of cards in turn. Our major arcana promotes skepticism and reflection, pushing querents to answer questions about unknown data rather than answer questions about the unknown, as might be found in traditional tarot. In particular, our major arcana pairs the traditional tarot major arcana with a value-laden symbol or character. These, in turn, are paired with a question, which asks the querent to consider the people involved in the analysis, the data as an artifact, as well as other statistical concerns. For instance, the one card, traditionally referred to as the magician, we describe as the analyst. This card pushes the querent to consider, did you seek advice from a statistical expert before analyzing your data? The chariot card traditionally denotes succor, providence, triumph, presumption, vengeance, or even trouble. Our chariot card shows summarization and pushes analysts to ask, is the level of data aggregation appropriate? As you might have seen in my previous talk, aggregations can cause all kinds of trouble. Our minor arcana contain automatically generated insights about the data set of interest. The insight itself is shown as a simple visualization, such as this bar chart. The interpretation of this insight is organized both by type of card as well as by number. The higher the value of the number, the higher the strength of the insight. We divide these types of insights into 4 traditional suits: swords, wands, pentacles, and cups, although we re-encode their meaning to suit our task. The suit of swords addresses data quality concerns. We reflect these concerns through a histogram, which shows the amount of missing or null values. The more missing values, the higher the suit. The suit of pentacles addresses extreme or unexpected numerical values, which we represent as a box plot, with outliers shown in red. The greater the corresponding z-score, the higher the card. The suit of wands relates to patterns of categorical variance. After sweeping across all configurations of variables, we select the configurations with the highest variance and present them as bar charts. The higher the variance, the higher the card. Finally, our suit of cups covers the correlation and relationship between fields. By computing Pearson correlation for every pair of variables, we select scatter plots that have the highest correlation. The higher the correlation, naturally, the higher the card. While these algorithms are intentionally simplistic and have many of the drawbacks of more pedestrian automated visual analysis systems, they still are able to form a coherent and automatic picture of the data set at hand. Now that we've met all the components, we can see the system in action. Here the querent selects a predefined data set, in this case, the world indicators data set. A new deck is then generated, which the querent then draws from and into the Celtic cross spread. They can then conduct a reading to find answers to their questions. We now turn to a staged reading to make concrete the experience and divine design of our system. We'll take the role of the querent, seeking answers from the divine. In particular, we ask, what may be divine from this world indicators dataset? Our first card is drawn into the context position, the 8 of Swords. It indicates that a large percentage of CO2 emissions data is missing. This suggests that questions about emissions may be unanswerable in this context, although it is troubling that this is only the 8 of Swords, suggesting that there are larger missing subsets. Next, we draw into the hidden influences position, the Queen of Pentacles, showing inbound tourism. This suggests that while many countries have few incoming tourists, there are some countries with quite high numbers, reducing the central mass of unvisited countries to near invisibility in the box plot. Finally, we draw biases into the advice position. This card is also the Devil, which in traditional tarot denotes unbridled id or harmful attachment. Here, he pushes us to consider our idish biases when modeling and measuring our data. After our reading, questions remain. How prevalent are these data quality issues? Is it possible that there are groups of high or low metric countries that are skewing other parts of the dataset? This reading is just one particular draw from this particular deck. A different querent will doubtless receive an entirely different set of cards with entirely different meanings that promote entirely different questions. The power of the stochastic and limited view is that it raises questions about what the querent didn't see, or might have seen in the data. We contrast this uncertainty and caution with traditional automated insight systems, where the querent might be left with the impression that the only insights that are recommended are important. Sortilege is subject to many of the same factors of concern as traditional automated analytics. It is inscrutable, fragile, and operates as a black box. Yet, we argue that sortilege is safer than existing designs. It encourages critical thought and skepticism, makes no pretense towards certainty, and requires users conduct interpretation themselves. By forcing a burden of interpretation onto the querent, we cut off the easy excuse that generated insights are objective or neutral. The human deals the cards, creates their interpretation, and links them together. They are an active rather than passive participant in the analysis, random and arbitrary though it may be. Conventional analytic systems go out of their way to build authority and perceived accuracy through tactics like suppressing uncertainty or using AI washing to convey unearned expertise. We make no such pretense. We go beyond simply improving the features of prior visual analysis tools and create a new one entirely, as our approach is natively physicalizable. This has untold and unmeasured benefits. For instance, instead of monitoring a dashboard to assess key metrics, one can simply perform a daily reading of a newly printed card deck. So as I was starting this slide, I realized I needed to have sound for the subsequent one, and so I need to stop my screen share and reshare it. I'm terribly sorry. Okay. Alt.chi papers usually include commentary from scholars in the community as a way to prompt discussion. Here we present a commentary on our work from a local scholar, Galen Harrison.
Data. Some people say it's the new oil. That's not true. The new oil is insight. In fact, the biggest problem facing innovators today is how to get the most insight out of the biggest data. What if I told you that there was a way you could get the most insight possible out of the largest of data? Folks, I'm talking about magic. If you don't believe me, the results speak for themselves.
In Sortilege, what are you doing when you engage in divination? Is it a life hack, a way to more effectively engage in positivist science, or are you actually engaging in a mystical process? In many ways, visualization recommendation systems are hyper-scientific. They want to do science about science, and the problems that Andrew, Anna Maria, and Michael are trying to address are results of them. By trying to engage mystical ways of knowing, Sortilege opens up the possibility that non-scientific ways of knowing may have a role in visualization. It is tempting to explain Sortilege and magic, witchcraft, and sorcery in scientific terms. However, this impulse should be resisted. Witchcraft is a situated phenomenon, and therefore necessarily cannot be understood through the disembodied scientific eye. Even if many of us may not accept magical perspectives totally, we should acknowledge that pure scientific rationalism can and will lead scientists astray. Rather than attempting to commandeer non-scientific perspectives, visualization and alt.chi research should seek to engage with them on their own terms.
Thanks, Galen. With that context in hand, we now reach our conclusion. We conducted this critical design exercise in order to comment on a trend in visualization research, as well as other fields, namely that there is simply too much trust being placed in unaudible automatic tools. We believe that as tool and systems builders, we should not just enable, but push our users to engage in critical reflection and skepticism as they go about their work. So what are you to do if you aren't a visualization researcher? Well, don't blindly trust automated analytics. Think more carefully about the who, how, and why of your data. And of course, question all of your assumptions. And with that, I'll conclude my talk. Thank you for your time and attention. I'll be happy to take any questions you might have here or on the internet. Well, elsewhere on the internet.
All right, thanks, Andrew. Yeah, we do have some time for a couple of questions. we can take chat questions over Zoom chat, YouTube chat, or raising your hand. And actually, so while we're waiting for a question, Andrew, actually, I have one for you. So, as you were discussing your proposal, it reminded me in some ways both of creativity cards as well as more traditional HCI kind of heuristic checklists and things like that. So I'd be interested to hear you compare and contrast your proposal with those schemes, as well as kind of for you to kind of illuminate what are the particular qualities that you hope the invocation of magic brings to this implementation.
Our work bears a close resemblance to creativity cards or mechanisms of creative constraint, such as Alipo or the Eno's oblique strategies, methods of sort of pushing you out of your normal lines of analysis. What our context has that's a little bit different than that is that it brings those things into what's normally sort of an austere, sort of like apparently objective environment. People tend to think of visual analysis systems like, say, Tableau or Power BI, or pick your favorite, as these objective like things of like get objective true answers. And the kind of thing that we look to do with this is to sort of shake people out of that. Really just question your assumptions when you're doing your data. And this connects naturally to the earlier talk on mirages, in that you can get a lot done by just being aware of what you're doing and being like careful and cautious of the way that you're approaching your analysis process. And so, like the Mirage paper talks about an automated strategy for doing that. Here we talk about sort of a way to sort of change the user rather than changing the analysis process. Hopefully they'll, through the invocation of magic, they'll be magically transformed into someone who thinks more carefully about their data.
Great. Are there any other questions?
You can go play with this demo or play with our system at viztero.github.io if you're curious.
All right. Well, I guess in the absence of further questions, let's do a Zoom thank you, Andrew. And if you could unshare your screen, and we're going to have Jenna share her screen in a moment. Jenna just co-hosted you. And so up next, while Jenna's getting set up, Andrew, we do have a question over chat. The context is, I'm a media artist in Canada. Have you considered the relationship between entoptic imagery, entoptic being Greek for between vision, which mediates endogenous interpretation, the human central nervous system interpretation of exogenous stimuli?
I really want to answer that question. It seems to be a well-formed question, but I unfortunately don't know a lot of those words. If you want to message me about that, I'd be happy to talk a little bit more about it. I'm sorry, I just don't have a good answer for you.
Okay, great. And the question asker wrote, sure. All right, so great. So it looks like Jenna has gotten the screen share going. So quick introduction. Jenna Cryan is a PhD student in our department, is presenting Detecting Gender Stereotypes, Lexicon versus Supervised Learning Methods. And this paper received an ACM Chi Honorable Mention Award. And so actually I figured, I don't think we've highlighted this yet. So we're presenting, in addition to Andrew's alt.chi talk you just heard, 7 talks from the main Chi conference. And it was actually astounding to me that of those seven papers, actually the one that started off Jazz's talk, received a Best Paper award, and an additional 4 received honorable mention awards for Best Paper, which in those categories represent respectively top 1% and top 5% of submissions to the conference. And so I think it's actually just quite phenomenal, that the Chi community is recognizing the quality of work from our students and colleagues with those awards. All right, and so Jenna, I'll let you at this point take it away.
Awesome. All right. So, hi, I'm Jenna. I'm going to be talking about some work that we've done with my collaborators at University of Chicago and UC Santa Barbara. We've been looking into detecting gender stereotypes with lexicon and supervised learning methods. So, biases in language influence how we interact with each other's and in society as a whole. And in particular, previous studies have looked at how gendered language reinforces gender stereotypes. Unfortunately, the current tools that we have for measuring gender in language are pretty lacking. There's been a long history of exploring the differences between the sexes, how these differences contribute to perceived gender roles in society, and how these contribute to perceptions of masculinity and femininity. However, these studies were done back in the 60s and the 70s, and what we want to know now is whether or not these previous studies reflect current gender stereotypes. In terms of modeling text and language, there's been a long history of using a very simple bag of words approach where a large body of text is broken down into single words or maybe a couple words tokens. And each of these tokens are assigned a score or a label. And collectively, these scores and labels are used to measure something in the text, whether it be sentiment analysis, or in our case, we're interested in gender. And these can be combined with word embedding models, which look at how these words are used frequently together. And both of these are very simple to implement. They've been used very well over the course of many years, but more recently, there's been more sophisticated approaches to this, which include deep learning neural networks. And these will allow you to input a single body of text. It could be a paragraph, a sentence, or an entire article, and get a single label at the end. Unfortunately, these require very, very large amounts of training data. For a simple NLP model that could require tens of thousands, if not hundreds of thousands of training data sets that are labeled. And that's not really reasonable for most researchers. So thankfully, in recent years, large companies like Google, who do have access to these large training data sets, will release pre-trained models that are trained for a generalized task, in this case, text analysis. And then it can be fine-tuned with a limited amount of additional training data. And up until now, there's been pretty limited research of how these models could be applied specifically to gendered language. So we want to find out how these lexicon and what we consider end-to-end approaches, where you can just input a large body of text and get out a label, how these approaches compare to each other. So looking back, the golden standard up until now has been the BSRI and the PAQ, which back in the 70s, they asked college students about what kinds of traits they would associate with masculine or feminine stereotypes that were desirable in US society. And then from that, they came up with these lexicons of feminine, neutral, or masculine words. And these studies have been used as such a golden standard that even nowadays, commercial companies are using these to measure gendered language. For instance, Text.io back in 2014 started up a service that, based on these specific lists, will look at what feminine and masculine toned words. They'll assign each word a score, add up the entire score for a job advertisement, and tell employers whether or not their job advertisements are gendered towards one specific gender or the other. But since then, more research has actually looked into how these BSRI traits have changed over time. And Donnelly et al. Looked at many, many studies that used the BSRI, and they found that women nowadays do not endorse the same traits that they used to back in the 70s. More specifically, our group recently looked at these companies like Text.io, and we found that the same traits are not endorsed over time. And by changing the language does not necessarily change the perceptions of these job advertisements. So overall, the last 50 years or so, this lexicon approach has been used as the absolute golden standard. And it's simple and it used to work very well. But I mentioned feminine and masculine could cancel each other out. For instance, in a job advertisement, if there's equally amount of feminine and masculine words, they could just cancel each other out and the employer would not know the difference. And it's very unclear whether or not these are able to capture how these words are used in different contexts. And as I've shown, they seem to be quite outdated because they are from 40 to 50 years ago. So our first question is how well these lexicons represent current perspectives. So we took a data-driven approach in order to create a new lexicon and look at how that compares to these previous lexicons. We took the Wikipedia data, which is all of the data that's on Wikipedia. And what we were most interested is language that describes. So we parsed out all of the adjectives and verbs that are used to describe a person. And then we asked Amazon Turk workers whether or not we looked at just the most frequent 1,000 verbs or adjectives because it was too much to ask them to rate all 10,000 words. So we asked them how well they would associate these words with a typical male or female in US society. Then we trained several different combinations of unsupervised and supervised machine learning models with these words. And if you want more details on the exact combinations that we used, I'd refer you to a paper because it's too much for this right now. But we looked at different word embeddings and different machine learning models, and we trained these models with our limited data set. And then we used that data to generate scores for the remaining words. And this entire lexicon, now we would be able to look at a large body of text and generate some kind of score of whether it skews towards masculine or feminine stereotypes. Overall, what we found is that the unsupervised models, unsurprisingly, did not work very well. The supervised models did show promise. And in particular, the best models that we found were the linear regression and the SVM combined with a word-to-vec word embedding model. But still, the results weren't very great. So what we found is that these lexicons don't reflect modern language use. We compared our lexicon to the words that were used in the previous BSRI, the PAQ, and Gauscher et al. Made a combination of these and some other gendered words. And we found that we were not able to match very many of those words, which shows that many of those words are not actually used nowadays to describe people. And overall, these models were not able to effectively work in context. The way that the words were used, they still were not able to accurately measure the gendered language compared to our user study. So next, we wanted to see if we can improve this lexicon methodology and measure gendered language in text with newer models. So in 2018, Google came out with what they call BERT, which is a sophisticated language model that's been trained on billions of words and millions of different articles of text. And this is a general language model that then can be used with a little bit of extra training data to fine tune for our specific task. So we needed an extra training data on large bodies of text. So we went to Prolific, which is a crowdsourcing site, and we asked people to find 4 articles online that either were consistent or contradictory with male or female stereotypes. We used this extra data to train the BERT model for fine-tuning for our task. And then in order to make sure that our original labeled data wasn't biased, we validated with an additional user study on the same training data, and we found very comparable results. Overall, our end-to-end approach, where we can just take a larger body of text, put it into the BERT, fine-tuned BERT model, showed way better accuracy than any of our lexicon approaches. Even after we expanded the lexicon beyond the labeled data, we still didn't find that it increased the accuracy significantly. And the end-to-end approach was able to capture much more context, even with our limited amount of additional training data. Furthermore, we looked at this, a real-world application of this. So based on our previous work, we had looked at how these state-of-the-art online tools compared or evaluate job advertisements. So I mentioned Text.io, and there's an additional model, Unitive, that uses a very similar lexicon approach. And we looked at how our end-to-end approach will compare when evaluating job advertisements that were pulled from LinkedIn.com. We asked the participants about how many women they would assume would be in such a job position, and how likely they thought that this specific job advertisement would appeal to women. And we found that our end-to-end approach was more successful at predicting these than both the state-of-the-art Text.io and Unitive. So looking forward, we know that gendered language is used all around us in society, in news articles, Wikipedia entries, biographies of everybody, all the way through movie scripts and novels that we read. And we hope that this work, by identifying how gendered language is used, we can hopefully improve it in the future and prevent gender stereotypes from negatively affecting us in the future. And I would just like to thank all of my collaborators, and questions are welcome now or through email.
There's a question already in the chat for Maribel.
I'll pull up the chat. I'm trying to pull up the chat.
Read it, Jenna. Do you want me to read the question?
Oh, yes, please. Oh, there we
So
go.
Maribel says, excellent work, Jennifer. A rigorous and detailed approach on an important subject matter that continues to plague us. It's not a question. It's a comment how awesome your work is.
Also,
but there's a question from Henry. Sorry, go ahead, Marshall.
So I was just going to say, we had a blip where Blaze was not made the host anymore. So if we can make him the host, he can't unmute himself.
Oh, yes. I see Henry's question right now. Whether or not I ensured that the Amazon Turk workers were Americans. We did restrict as much as you're allowed to on Turk to Americans, but that's assuming trust on behalf of the workers that they are American. But we did try to specifically restrict our workers with Turk and Prolific that they were American, because we understand that cultural differences regarding are very significant. So we did try to, yes.
Are there, now that I can unmute myself again, are there any other questions? Well, while we are waiting for other questions, I guess, I guess, Jenna, it might be hard for you to answer this definitively, but, I guess as you move kind of from like the lexicon kind of approach to like, your end-to-end approach, and like, using things like BERT, both the model change and the data, both the model and the data end up changing. So do you have a sense of like, is it the model that's contributing to the better performance? Is it the having extra data that's contributing to it? Or you kind of, your spectrum?
That's a really good question. Yeah, that's a really, really good question. So we hope that by using the Wikipedia data dump as ours for the lexicon approach, and I didn't show it, but we did do a breakdown of where people sent their articles in from. Most of them were from Wikipedia or a few other news sites were the top ones, but very significantly from Wikipedia. So we felt that the data was comparable for that. It is very different, especially how, people writing in text online versus how they use it also in speaking language. But we hoped that the training data for both was comparable, but certainly, again, looking at, different cultures and different mediums, it could change the results.
Great. Are there any other questions? All right, well, so in that case, let's thank Jenna one more time, I guess virtually on mute.